Hi, I'm Paul Kyogan from GKTuition, and in this video I want to talk to you about induction. Now the question I've chosen to go through is 2016 Paper 1, Question 4, Part A. In this question, we're asked to prove by induction that a to the power of n minus 1 is divisible by 7, where n is an element of the natural numbers, the natural numbers being whole positive numbers. Okay, so now for your induction, our first step is going to be, we're going to test for n equals 1. Okay, now the reason we're starting off with 1 in this case is because I was asked to prove that my statement is true for all the natural numbers, which means that I'm going to start off with the first natural number. Now, in certain scenarios, it could be different to this. We could have been asked the same thing. Prove that a to the power of n minus 1 is divisible by 4, is divisible by 7, where n is greater than or equal to 4, and n is a natural number. So it could have said that, in which case we would have started off by testing for n equals 4. We would have started off with the first number. However, in this case, it just said natural numbers, so I have to start off with the first natural number, which is 1. So to test for n equals 1, in my original expression, wherever there was an n, I just sub in a 1. So we just get a to the power of 1 minus 1, and 8 minus 1 is clearly 7. 7 is divisible by 7 because 7 divided by 7 is equal to 1. So I can just put a tick beside that and say that it's true. So my first step in my induction is relatively straightforward. Now my second step will always be the same. So my second step is an assumption. And I'm going to assume it's true for n equals k. So assume true for n equals k. And what this means is that I'm now going to sub into my expression, everywhere there's an n, I'm going to sub in a k. And I'm going to assume that that is divisible by 7. So I'm going to assume that 8 to the power of k minus 1 is divisible by 7. And for the rest of this question, I'm going to work off of that assumption. So it's a good idea, I'd always highlight or put a box around my assumption because you're guaranteed to need to use this in order to simplify part 3. Now the third step, again, in my induction will always be the same. My third step is to consider n equals k plus 1. Or in other words, consider the number that's directly after k. So consider n equals k plus 1. So in this case, everywhere there was an n up here, I'm going to sub in k plus 1. So I'm going to get a to the power of k plus 1 minus 1. And now this is the tricky part of the question. I need to try and prove that this is divisible by 7. Now my a to the power of k plus 1, I'm going to use one of my rules of powers to simplify this down. If you go to page 21 in your log tables, one of your rules of powers is that a to the power of p plus q is equal to a to the power of p times a to the power of q. That's what I'm going to do with this one. a to the power of k plus 1 is the same as a to the power of 1 times a to the power of k. And then I've got a minus 1 at the end. So all I've done is, if I'm adding them together, I can just write it as a to the power of 1 and a to the power of k. So now I can simplify this one further. I want you to view this as 8x. Okay, I have 8 times a to the power of k, or I have 8 times this unknown. But I want you to view it as if it was an 8x. So imagine what we're going to do on the next line is we're going to pretend that the first term is just like 8x. I have 8 multiplied by a variable. And I'm going to split this term into 2. And I'm going to split it up into 7x plus 1x. So if I have 8 of them here, I'm just splitting them into 2. Which is exactly what I can do with this. I have 8 a to the power of k's. I'm going to split that up into 7 times a to the power of k plus 1 times a to the power of k. And then I have a minus 1 at the end. Now I'm going to finish the rest of this question at the top of the board, so if you want to freeze frame this one and just take it down. Okay, so you'll notice that I've taken down my assumption again. My assumption was that a to the power of k minus 1 is divisible by 7. And where we left off in the last frame was I had 7 times a to the power of k plus 1 times a to the power of k minus 1. Now straight away I can say that this first term is divisible by 7. It is divisible by 7 because the coefficient is 7. It's 7 times a to the power of k, so clearly that is divisible by 7. I know that 1 times a to the power of k minus 1 is divisible by 7 because that's my assumption. So I can say it's divisible by 7 from assumption. So that's enough to conclude part 3. That's enough to I can just literally write it in English, and I can explain that, and I can explain that. Now for part 4, I need to make a conclusion. And your conclusion in induction will more or less always be the exact same as this. So I can say the proposition is true for n equals k plus 1 if it's true for n equals k. So in part 3 I proved that it was true for n equals k plus 1 based on the assumption that it was true for the previous number. So I know it's true for this number if it's true for this number. However, but in the first part of the question I proved that it is true for n equals 1. If it's true for n equals 1, it must be true for n equals 2. It must be true for n equals 3, which means it must be true for n equals 4, and so on. So I'd say 2, 3, 4, ... for all n is an element of n, for all the natural numbers. Now your conclusion will always be identical in your induction, except in the cases where we didn't start off with n equals 1. So at the start of the video I explained to you how you might not be starting off at n equals 1. So if I was starting off at n equals 4, I would have said it's true for n equals 4, therefore it's true for 5, 6, 7, all the natural numbers. And at the end I'd always just reiterate the way it was phrased in the question. So in the question they asked me to prove it for all the natural numbers, so I've reiterated that at the end of my conclusion. Okay, so I hope this video makes sense. If anyone's unclear on any of that, then just send me an email or let me know in class and I'll try and explain it differently.